it was not here. Beatrice, did you have a chance to look at the video? It's okay. I'm not calling you out. I was just curious. So there might be a few things that you need to go back and look at a little bit. So really, we are continuing on with what we did on Friday. Not too much new, okay? So what we have in this first example is a table of values for 3 functions. So this is just a fancy table of values, right? They all have the same x values, and then f of x, g of x, h of x, these are the y values. So these just make ordered pairs for each of the 3 functions. And we're going to use it to perform the operations given to us, okay? So we need to find this composition and this composition and then add them together. And if you remember, we always start furthest to the right. So we would start with the g of 2, that's our inside, and we would apply it out here, well, to the f and then times 2, I should technically say. So g of 2, remember the number in the parentheses is your x value, so that's right here. So g of x, g of 2 is negative 3. So I would have 2 times f times negative 3, right? So g of 2 is negative 3. And then I just keep going. F of negative 3, so here's negative 3, f of x is negative 3 is negative 4, and we get negative 8, right? So 2 of f of g of 2, 2 times f of g of 2 is negative 8, okay? Then we would do the other one, h of 0, so remember, 0 is your x value, go down to h, that would be 3. Then we would do g of 3. Here's g of 3 would be 2. And then, of course, that's 6. Add them together, we get negative 2. Okay. These charts can get a little confusing. So try to remember that the number in the parentheses is the x value. And then you're trying to find the y value for whichever one it's saying. So g of negative 2, x is negative 2 on the g function would be negative 1. Okay. H of negative 1, so negative 1 on the h function would be 1.5. Same thing over here, g of 2 is negative 3. And negative 3 on the f function is negative 4. So just multiplying these together. 1.5 times negative 4 is negative 6. In my calculator. Good? Okay, look down here, A, B, and C. We are given 3 different compositions, and we are also given 3 different functions. Again, f of x, g of x, h of x. These are all relations, right? Relations are ordered pairs. This was just in a table of values. Here it's written as algebraically in an equation form. And in a minute, we're going to be looking at graphs. Just all different ways of working with ordered pairs, basically. Okay? So following our pattern here, we always start on the all the way to the right and go to the left. So g of x, of course, is x minus 1, given to us. We're going to plug it into f of x right here. And since it's a binomial, we'll put it in parentheses. Now the question is, what are the, it says to describe the transformations of the composition of functions. So our parent function, the outside one, was f of x. So quadratic. What happens when I put x minus 1 in it? What direction would that move all my points right here? Right 1, Thomas, yes, right 1. So it's really important that you guys remember all the different transformations. Like when in the parentheses, that's your horizontal, left or right. Let's try another one. H of x into f of x. So I'm going to take h of x and plug it into the same place. And I do need parentheses, right? Because I'm plugging in more than just a single number or letter. That is so important because this and this are two different things. These are two different things. Those parentheses mean everything. It means the difference between a vertical stretch and a horizontal shrink. Okay? So inside, somewhere special, secluded with the x, sometimes it's up in the exponent, sometimes parentheses, under a radical, inside the absolute value. If you're separated, if they're like secluding themselves or off by themselves, that is a horizontal dilation, we can say. Horizontal dilation. Dilation is like the umbrella word for stretch or shrink. Okay? But remember, when it's horizontal, you have to flip your fraction. So this is 2, so it would be by 1/2. Okay? So if that were a fraction, let's say it was 1/2 given, we would write it as a 2. You have to remember that for the horizontals. Okay? And then the last one, f of x into g of x. So f of x is, of course, this. We're going to plug it into g of x where there is an x, which is right here. And we don't need parentheses. You could, I guess. It would look weird, but I wouldn't. So x squared minus 1. What a big difference parentheses make, right? This one versus this one. These are not the same thing. This was right 1. What's this one? Down 1. Yes. Leah, are you paying attention? Why do you have that? Come on. Let's do this. All right. We only have one more example to do. That's it. And then we're going to go to the homework. And there's a word problem in the homework, one, and I'm going to do that with you instead of doing it in the notes and the homework. I feel like Friday's notes and homework were a little heavy. Unless you, sometimes that happens. I can't really control it. You guys see, I do try to skip things that I know we don't need. But in this case, I shortened this one, and so you should have time to go back and work on Fridays if you didn't get a chance to finish it. Okay, so we're going to complete the table of values given a graph. Okay, so let's see what we have here. We have a graph of f of x labeled, graph of g of x labeled. They're sharing the same coordinate plane, and we're going to use that to fill in these. And we're not even going to do the whole 2 columns. This is kind of like, after you do a few, it's like, really? You want me to do all of these? And there's one of these in your homework, so you can just do the one in the homework if you want to practice more. Well, you do. So anyway, f of x and g of x, and then we'll talk about part B, which is finding h of x, okay? So remember, these are the x values, and they share the same x values, but their y values could be different. They could be the same. So for example, at -4, which is right here, f of x is down here, right? So when x is -4, f of x is also -4. When x is -4, g of x, which is up here, is 2. Right? We're just pulling the y values off the graph. We're finishing the ordered pair. So at -3, f of x is down, right? Here's my f of x. So -3 is -2. Can't see it, so I'm cheating and using my feet. My eyes are really bad. And then at -3, my g of x, it looks like it is +1. Are you guys seeing where I'm getting these numbers? Because it can be confusing at first. So tell me if not. -2 for both of them, the y value is what? 0. Let's just do one more. X is -1. F of x is 2, right? -1, 2. It's just an ordered pair, written a little funny. And for g of x, it would be -1. Okay, so let's not go ahead and finish those. Let's see what h of x is. H of x is basically an equation. H of x equals whatever f of g of x is. So g of x into f of x will give us h of x. Okay, so let's start with g of x. So to get h of x, I'm going to start with g of x. So for this one, it would be g of -4. We already found that. G of -4 is 2, right? That's what that says. And you can go to the graph and confirm that. So what we have now is f of -4. That will give me my h of x, right? So g of negative 4, whoops, what did I do wrong? This should be a what? 2. So sorry. Let me go back. G of negative 4, right, we're just plugging this x in right there. G of negative 4 is right here. It's 2. Then we keep going. F of 2, I'm going to go to the graph. So f of 2 would be 1. Okay. Let's do another one where I don't mess up. Okay, now we're using negative 3. So g of negative 3, we found that. That's right here. G of negative 3 is right here. It's 1. So now we're going to find f of 1. And if I had completed this, it would be here, right? F of 1 was here. We didn't finish it, so I'm just going to the graph. So f of x right here at 1 is 0. This part can be confusing, as you can see. I messed up that first one. G of negative 2 is 0. Okay, so g of negative 2 is 0, so now I'm left with f of 0. F of 0 is 1. And last one, g of negative 1. G of negative 1 is negative 1. Then f of negative 1 is 2. Same with this one, right? That's what this is. F of negative 1 is 2. Okay, so just, this is what I'm doing. H of x is whatever f of g of x is, and that's how I fill that in. And then part C is like graph the points. Graph x, h of x. So everybody shares the same x's, and then what did we get for h of x would be what? So like negative 4, 1 would be our first point. Negative 3, 0. Negative 2, 1, and so on. Negative 1, 2. And we would connect them, go through the whole chart, but you don't need to. Okay? There's one of these in the homework, so if you got a little confused, use the key, ask me for help, talk to your neighbor, whatever. Right? So just remember, that little number in the parentheses is x. Okay? It says it here, but if you replace it with something, if you know it's x. Okay? All right. So we're going to go to page, well, let's go ahead and set up our homework page. You guys are going to go to practice set 2. One through 13, omit number 8. Omit means do not do. 1 through 13, omit number 8. And then we're going to do number 16 together first, which is on page 188, I believe. So I'm going to do a homework problem with you right now instead of making the notes longer, which is number 16. So go ahead over to number 16. Let's do this word problem together. You have it written down? Okay, so you go to a restaurant, and they're giving 15% off of entrees. Okay, so whatever you order, whatever entree you order, you're going to get 15% off. And on top of that, you have a coupon for $5 off. Okay, so let's write two functions that model the discount and model applying the coupon. Okay, so we can so let's get used to things like this. Like, how do we write a function? What letters do we use? Does it matter? Let's try to follow the rule that if they give us variables, like if they called the discount d of x, we'd use that, and coupon c of x. But if they don't give you that, you can use whatever you want. Like, I'm kind of boring, and I like to just go back to f of x and g of x. They're just easier. This is most common to me. But if they give it to us, and I need to do a better job of that too. If they give us the variables, let's use the ones they give us. So we're going to make a function for using the coupon and one for making a discount, okay? So, like I said, you can use any letters you want. I'm going to just stick with f of x. So if I'm going to get 15% off of the price of an entree, okay, let's just call the entree x, right? What would that look like? 15% off. times what? I hear lots of good numbers. You guys are thinking. I heard times, and that's true. We're multiplying the price of the entree times what percent? How much are we paying? Think of it in the positive. How much are we paying? Close, Lexi. 15.85x. 0.85x. 85% of the price is what you will pay. That's how much it's going to cost you. Like if it's $10, 100% of that, right? 100% of that is $10. But then if I do 85% of that, I'm only paying 8. I don't know why I need a calculator for that. I only need 8. I'm only going to pay $8.50. That's what I'm paying. Okay. Mm-hmm. This is, okay, so this is, we're going to put them together in a second. Yeah, so she's looking ahead, but you have a coupon too. Yeah, we're going to talk about that in a second. And then the coupon, let's call G of X, or whatever you want. How would I show $5 off? X minus 5, right? Whatever the price is, take off $5. If it's $10, you just are subtracting 5. Geometric, arithmetic, linear, exponential, not really exponential. Okay, all right, so we could come up with those two functions. Now use a composition of your two functions to model how much you pay for a dinner entree if the cashier applies the discount first, okay? So this one's going to be discount first, this one's going to be coupon first. So we're basically doing the same thing, but just changing the order, okay? So remember, whatever we do first is on the inside or furthest to the right, all right? So that means it's going to be G of f of x. We're going to do and check it, make sure. If I'm going to do the discount first, that means that should be what's all the way to the right. And my f of x is my discount. So I would take my discount and then apply it to my coupon, okay? So let's do it. Let's show that. Let's take f of x and plug it into g of x. So wouldn't that just be 0.85x, I put it right here, minus 5. Makes sense, right? That's the equation I would find. That's the equation I would use if I was at that restaurant and I wanted to tell them which one to do first, okay? Then I could do, of course, it'd be the other way around. I'm going to take my g of x, which is this whole thing, and plug it in to f of x. So that would be 0.85, take out that x, plug in g of x. We can clean that up a little bit by distributing. Can't you already tell which one's better? Look at it. Which one is better? I mean, before we even finish the question, how do I know which one's better? Look at them closely. The discount first. Look at it. You pay 8. It's doing 0.85x, then subtract $5. This is only going to subtract $4.25. How much more is the entree if the coupon applies the? How much more if the cashier applies the coupon first? 75 cents. That's right. 75 cents. Look, $5 off, $4.25. We already learned on Friday that they are not commutative. G of f of x and f of g of x are not the same, right? They don't equal each other. It does matter which one goes first in most situations. Are there exceptions to the rule? Of course, but generally speaking, these will not be the same thing. Okay? The difference between $5 and $4.25. 75 cents. Okay, let's go back. I'll put the key up for the homework. And listen, if there's anything, you didn't quite get, you need help with, I will help you. If you want a test review early, they're yellow on this desk up here. They're stapled kind of in a funny order. I don't know. It's so hard. It's like the hardest thing in my life, I swear, is making like copies, front, back, combining pages. Where do I staple? Where do I hole punch? I don't know. And then there's a line of teachers behind me wanting to use the copier, and I just get flustered. Look at the top. This one's like always. Otherwise, the one just should work. I did that on all of our test reviews. And what number? Oh, okay. Good question. No, you're right. It's already in like the quote unquote parent lecture. It was already done. So in the first one, it went up to the up 3. Then what did you do to it? We moved it from there left 4. Okay? So if it was already in the first one, you don't have to okay, yeah, number 7 is algebra skills. Think about it. Let me know. It's really hard. Yeah, to do that. the number 11, so I thought it looked weird. And I've never really seen it written like that, but I went ahead and graphed it. Oh, I don't want to take it down yet. But when I graphed the parent function and the one with the x plus 3's in it, it literally took it to the right 3. So you have never seen it written like that. It's right. So you don't simplify that. Well, can you simplify that? I know, but we don't do it any other time. Like, you can simplify this. I can make that 4x squared. When you use it unsimplified, you really see what the transformation is. Like, from here to here without simplifying, all we do is move our point left and through. Right? If I squared that, negative, minus, I wouldn't see that very clear transformation. But the final answer to be negative. So, did you find f of h is up to 3? Yeah. In the okay. Then you just make another equation. So, f of h is up to 2 is just is that, right? So that's equals mu alpha. This equals blah, 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 and then you solve the equation. There's that. Oh, no, you don't have it. You start saying actually. Oh, yeah. So, it isn't like clear up. I know, that was a little for sure. Staples in my back pocket. Why is staples in my back pocket? I mean, the things I find in my laundry. you guys, how do you know, because I don't have the answer to this question, look, how do you know that f of x is going down here, or does f of x go like that? Do you guys see what I'm saying? Look, how do we know that it goes straight through? Is there a break in it that's telling us that? I don't think so. There is a little break, but it doesn't. Was there a break in the first one that they gave us? No. All right. Yeah, that's confusing. I'm not sure. I don't know. I can't think of any reason how you would know that. Yeah. Hopefully it's not on the. Let's see if when we do our progress monitoring, if it's on there. If so, I'll write a letter to, or write a.